Hey guys, welcome back to our channel. My name is Andrea, and I will be going over Unit 1, Lesson 3, Quantitative Research, Correlational Studies. So, what is correlation? You should always remember that when there is no variable manipulated, causation cannot be inferred. So, correlation does not equal causation. Correlation is when two or more variables are measured and the relationship between them are mathematically quantified. Correlation is a measure of linear relationships between the variables. And in order to illustrate the correlations, we use scatter plots, where each dot represents an individual. So the different correlations, positive, zero, and negative correlation. Positive correlation is when both variables go the same direction. This is when both variables goes up or down. Zero correlation is when one variable increases or decreases, the other variable increases or decreases at the same unit. Negative correlation is when one variable increases and the other decreases, and vice versa. So for example, a positive correlation is when the more time you study, the higher the grades would be. A negative correlation would be the more time you spend on your phone, the lower your grades would be. Effect size and statistical significance. Effect size is the absolute value of the correlation coefficient. This is a number from -1 to 1. Statistical significance is the likelihood of a correlation being caused by chance. And then here you would see a table that is also available in the course companion, which would explain how effect size and statistical significance would usually be interpreted. So a correlational coefficient of 0 would suggest no correlation, while a correlational coefficient of 1 suggests a strong correlation. The conventional cutoff point for statistical significance is 5%. So a statistical significance of less than 5% indicates that the results are statistically significant. This means that a p-value less than 0.05 or 5% means that the result is statistically significant. So this means that your results have a 95% chance of being true. First, we have the third variable problem, where it states that there is always a possibility that another variable, the third variable, explains the correlation between x and y. Curvilinear relationship is when variables are sometimes not linked linearly. For example, the arousal and performance relationship. And the third one is the spurious correlations. This is when multiple correlations between multiple variables are calculated, which leads to the possibility of statistical significance resulting from chance. Since there's so many variables included, calculations could be wrong and it could not be statistically significant even if it says so. Okay, sampling, generalizability, and bias in correlational studies. Sampling and generalizability are similar to experiments. In sampling, the target population is identified and the sample is drawn by random, stratified, opportunity, or self-selected sampling, very similar to experiments. Generalizability. The results are directly linked with sampling and depend on representativeness of the sample population. Bias in correlational studies can occur on level of variable measurement and the level of interpretation of the results. In the third variable problem, a researcher can make this more credible if the third variable is considered in advance and x and y is studied accordingly. In spurious correlation, it could be more credible if the interpretation of the results would be studied carefully. Effect size and level of statistical significance would be considered together. So that is it for this lesson. Thank you for watching this video and make sure to stay tuned for our next lesson. Bye!